So here I am. It's a glowworm ultracom, which to be fair wasn't a bad boil. There's a few leaks on it, and these are quite well known for leaking on the diverter valve. Sometimes on these the water sensor can seize up as well. There's the aqua sensor, so that activates your hot water demand. So basically there's an impeller that spins. If your automatic air vent, I've left mine open. Expansion, always check the pressure in that. This one's been installed by a decent installer. You've got a magnet filter on the return, you've got a shock arrestor, and you've got an additional expansion vessel. That's there because obviously there's quite a few radiators. PRV, you have your NTC sensors just here, look. Always give them a bit of a move, just a centimetre or so. And what that does, that allows the NTC to connect onto a different part. Just there you have the pressure sensor. So if you get an F75, it could mean the pressure sensor needed to come out. Sometimes you get some magnet and gets stuck. Because what happens is, when the water gets hot, the pressure inside builds up 0.2 bar. If there's muck in it and it's seized, it won't read that. So T20 screwdriver, one there. There's one bottom left. Drain it down there, which isn't really advisable, but before I fill up, I'm going to just wash it and check it's all clean. Phillips, just behind there, just to give it a bit of a tug on. So this is the diverter valve. So each time it goes from hot water to heating demand, this ball moves up and down. And usually what makes these leak is water quality. So let's just wipe it on there. And usually it's just in there where it leaks. So when you go to put the diverter valve back in, just be aware there's a little notch there, and on this one, the new one, there's also a notch just where my thumb is, look. So make sure that notch slots in that one there. And always put the wiring on the top, so if you get a leak it's not going to touch the wiring. So this is the pressure sensor, and usually what happens is muck gets in that barrel just there, and you'll get an F75, which means the pump isn't spinning. But really, it's this, it's seized, it's not activated the increase in pressure. So now during the system, I've took this out from the back. I'm just going to take this out and give it a clean, and usually what you'll see is there's muck in the back. Usually you'll see there's muck in the back of this. There you go. So I'm probably going to dip some vinegar in that and leave it to soak a while. So I've changed the diverter valve. I've taken the pressure sensor out, put a bit of vinegar in it, hit it and got a little magnetite out of it. The next thing I'm going to do is check the expansion vessel. So here's the expansion vessel. I've put my pump on the Schrader valve look. Always put a bit of grease on it. So if you smear some grease on it and you get to pump air in, it'll seal it. So put it on like so. It's empty. So I'm going to charge that to about 1 bar. So whenever you're adding pressure to the vessel, always make sure that you have an open end. So while you're pumping pressure into the vessel, you're actually not pushing against anything else, so it'll give you a false reading. So grease, Schrader valve is on, pumped it up to 1 bar. So on this side of the vessel, there's 1 bar. On this side of the vessel, it's just going to be empty until we get charged up. And you must always check the charge vessel in this, because it prevents the diaphragm moving too much and tearing. Also, sludgy water can tear it on the edges as well. I've drained the hot and cold water down. I've repressurised the shock arrestor. Heating's still staying drained down. Repressurised. I've fixed the leak. I've cleaned the PRV pressure sensor. The next thing we'll do is clean this plate to plate. You don't always have to do this amount of work, but because I'm here, everything's drained down. Well, why not? The whole thing's in a cupboard as well, so it makes sense to do it while I'm in this situation. So I'm going to take it out, clean the heating side of any sludge and scale, and then pop it back in again. Out. I did 2 screws, lifted it up. One of the reasons why I have to fit a shock arrestor is because with all this plastic inside, it can create leaks. Now I took the plate out. At the back, there's a filter. I'm going to give that a wash. The plate to plate only goes back one way. And these slide on like so, and the screw goes in there. Before you fill up, always check the washer. That one could have created an issue because it's back in the drain off valve. So I'm going to have to inspect that now, take it out and see if it's okay. Next up, take the filter out, just give it a clean. Oh wow, look at the lumps on that. So now I took the filter out and washed it. I'm going to drain this, I'm going to open this up, drain the water out and put some inhibitor in it. So next thing, while I'm here, I'm obviously going to do a flow analyzer test and we'll do a tightness test. I'm going to clean the condensation trap as well. So there's the trap. As the flames condensate, the water and salts from the flame come down in the condensation trap. I'm going to give that a clean now. So now boilers are becoming a lot more advanced, a lot more efficient. You have interfaces. I'm a great believer in an interface. The better the product, the better the interface. You can service and fault find using the interface. Make the most of it. Get the instructions out, learn the interface. I can save you a fortune on fault finding and stuff. So here we go. Press mode. F75. Enter. D00, that's to range rate it, how powerful you want the boiler to be. That'll tell you if there's 24 volt controls, 240 sorry. I'll tell you if the pump's on. Pump power. Hot water temperature. This is a brilliant one. That'll tell you if there's hot water on. So this is good. D00, D22, 0. Hot water's on. D33 and D34 is how fast the fan should be going and how fast it is going. D33 and D34 should be within 200 of each other. D35, that's the position of the diverter valve, so it's in hot water mode at the moment. D36, that's flow rates. That'll tell you if the aqua sensor is working, that'll tell you if it's picked up the water demand. Here you have the flow and return. So there you got flow, return. They need to be within 20 degrees, if not pump or airlock or pipework issue. This is the ionisation. This is how good it's burning. So are you ready? Look. If it's below 400, it's burning good. There you go, it's a good neat flame. And that's how you fault find using the interface. That's just helped me check the circulation, the position of the diverter valve, the flow rate, the hot water activation and the fan.